Welcome to Natural Habitat Adventures, Daily Dose of Nature, Fantastic Fungi, the largest living network on Earth. Presented by NatHab expedition leaders, Annie Van Dinther and Arpita Dutta. I'm your host, Rob Mess. Thank you all so much for joining us today. Over to you, Annie.
Thank you, Rob, for that fantastic introduction. And most of all, thank you to all of you for signing on today. This topic, buckle up, because it is going to be quite a ride. It is really interesting, and it's kind of blowing our minds, honestly, the more and more that we learn about it. I could not be more excited to be presenting today with my friend and coworker, Arpita. How about you introduce yourself a little bit?
Yes, hi Annie, hi Rob, and hello everyone. And before I could introduce myself, I would say from all through the India, today is a huge festival here, which is Deepavali or Diwali. It's a festival of lights. So every house is like lighted up with candles, with diyas, with small rice lights. A lot of decorations has happened. So from all the Indians and with lots of love, I am wishing you all a very happy Diwali as well. So this is Arpita, and I have been working with NatHab since 2018. And yes, and after that, presenting these webinars and finding myself more and more into this and to the family of NatHab. And yes, so yeah, and honestly, because of this festival, I might have some problem of network because everybody is wishing one another. So if anything happens, please excuse me for that. Thank you.
Okay, so Arpita, happy Festival of the Lights. We're so excited that you joined us today to talk about this topic. We are going to read something, which is not normally how we start these, but I'm going to read something that seemed like the best explanation that we could give for this. So it goes like this. Fungi live in all kinds of organisms, on surfaces, in and below the soil, in the air, in the water, in deep ocean floors, and inside solid rock. Who can do that? In these places, fungi are not merely present, they are structural. Their interaction with other matter has played an essential role in making the world we inhabit. The symbiotic merging of algae and fungi to form lichens enabled the rootless ancestors of all of our plants to emerge from water. 90% of all plants depend on fungi for minerals. Fungi, some people would say fungi, can eat more rubbish and even oil spills. We can use them in numerous ways: drugs, cooking, even furniture building. And when we look closely, we meet large, unsettling questions. So that is the foundation. That comes from an article in The Guardian. That's the foundation of what we're going to do today. And it seems like the very first thing we have to do to understand this incredible world is just to say, what the heck is fungi? What is fungus? And to do that, we first have to understand the plant and the animal kingdom. So Arpita, tell us about the plant kingdom. What makes a plant a plant?
Yes, Annie. Before we get into the topic of today, even if we think that how our world is made up of, so it's just the 1/3 of land and the rest is water. And as we know that there are a lot of creatures, and both belongs from the plant kingdom as well as the animal kingdom. So if we come to plant kingdom first, yeah, the first thing when we think about plant is green. And when we think about green is the freshness. And that freshness brings tons of oxygen for which we are still surviving. And with the plant is the nutrition. It's not only that they give oxygen, they give out oxygen. We eat a lot of vegetables and foods, so of course the nutrition, it comes from there. And the furniture you are talking about, even that comes from the plant. Where we are building our house, our home, our furniture, and everything, even medicines. So the plant kingdom is huge. The more the animals are, even we can consider the plants are. And we think that the plants came on this planet way before than the animal arrived. So this is a little about the plant with the system. The plants have roots as well. But now we will shift to a little bit of the animal kingdom as well. In animal kingdom, we have two parts if we can break it. One is with the vertebrates and another are the invertebrates. So we belong with other families in the vertebrates because we have the vertebral column, and the invertebrates, which are, you know, all the wriggly wiggly creatures, which are even now, I mean, way beyond numbers. Annie, have you just imagined, like, if we put together this plant and animal kingdom together, how big and how enormous itself that this two kingdoms are. But on top of that, we have another kingdom which is really making us think, like over here, completely, I think, how you say that, buckle up for this webinar. I think we have to tell ourselves, buckle up to learn about this thing, which is, I mean, with all the new study, with the new science and research, so many things are coming about this kingdom, which is the kingdom of fungi, or fungi, how you say it. I think it's not even enormous, it's infinity. Now we are standing in the infinity where we don't know from where to start or where to end. We haven't touched the tip of this kingdom yet. And already it's mind-boggling. If I'm not wrong, Annie.
You're not wrong at all. And I think we should tell the viewers today, you know, when we teach you about, for me, when I teach you about bears, I have spent a lot of time on the ground watching bears, observing them. I used to research whales. I feel confident in that. We are learning right along with you. Well, I have obviously stood on the ground beside mushrooms, fungi, lichen, all of that. The observation of what is happening below that is, as Arpita said, new. And it's an incredible thing to be learning about. So join us now in that learning of what it is. So Arpita, tell us, what defines this kingdom of fungi? What makes something fungus?
So if we first think about fungus, I would go back to almost 10, 15 years, say. Are you a vegetarian? Okay, do you take, mushrooms? This is a very likable question, don't you think so? Because we consider the mushroom as a vegetable. That is a plant, substance of a plant. But now, suddenly the question has arrived whether the fungi fall under the plant kingdom or animal kingdom. I mean, that's a huge question. It's a debate right now, but gradually the scientists have found out that fungus are more close to animals than plants. And how is that so? So this is, Annie, what I'm telling. It's like we could not observe that. It's all on the basis of study and the new research, whichever is happening. So it's really very difficult to present like in that way. But how they have stated onto this research, I would just like to share with you all that when we talk about plants, they are autotrophs, autotrophic, you can say, that they have chlorophyll, they can make their own food, though they don't move from one place to another, and they like give out plants give out oxygen. So these are few things of plants. And animals, they can move from one place to another, and they are heterotrophic organisms. That means they consume on other substances or others to get the nutrients. We can't prepare our own food, and we give out carbon dioxide. When we break down, everything happens. So, and of course, so this thing comes with a fungus that they cannot make their own food. They have to depend on the other consumers, like some dead and decaying thing. They could be parasitic. They could be mutualistic relationship could be there with the fungus. And you know, Annie, they breathe out carbon. I mean, when the chemical digestion thing happens, they leave the carbon in the as a nutrients to the soil or to the ocean or to the atmosphere. So it is more closely related to the animal. It doesn't end there. If you go to the next slide, you will find we have known that cell is the unit of life. And in a plant cell, the first thing comes is the cellulose. And for animal cell, it's the it's not the cellulose, it's the cell wall. There is no cell wall in animal cell. But over here, the cell wall is made out of chitin. So it's very different. And the plant cell won't be a single cell organism, right? I mean, plant cells are not like that. But in case of fungi, they are single cell as well as they are multicellular. So this whole combination of this, and starting from that single thing, unit of life, Annie, let's go back millions of years ago, and there, how does it feel that this fungus has the common ancestor like us? I mean, we share the common ancestor. I mean, that is called a koan of flagellates. Flagellates means the flagella, the flip they have to move on or to settle in place. So this has, I mean, the same composition or the same way how it has, I mean, with evolution, it has changed. Human has the same thing. I mean, I think we need to study more on this. We just got to know about this, but there are not much study, not in depth happened yet. But there is just, I think, a little fraction of things we have come across that fungus are more close to animals.
It's interesting because I think when we think of our body and fungus, we think of it almost like a disease, right? We kind of equate those words together, but it's so much more complicated than that. And we really do have similar building blocks to the fungus, right? The foundation is more similar between animal, humans, and fungus than it is between plant and fungus. But really, I think it seems like they're in their group all of their own. I mean, they definitely do need this whole other kingdom to be what they are. One of the things that we have in common here is the breakdown of waste from other organisms. So tell us about this.
So we can say that, see, we have seen that some food get waste, or maybe a rotten apple or an orange. Especially on an orange, you get to see that greenish thing or the bluish thing had started taking up, and we say, oh, it's gone, we have to throw it. So we have thought about it, that it got fungus, but we never thought about the depth of it, that how and why these things are happening. So imagine this fungus has the ability to decompose a lot of things. Even they can decompose the cellulose and the keratin. They have that ability to do that. And they are the finest decomposers. So they break down all the organisms and recycle the nutrients and get them back to the atmosphere or to the nature. So it's like you are taking the waste products and giving out something good. It's like, you know, the exchange of things doing nowadays that you give 10 plastic bottles and you get a chocolate. So this is something like that. And they are doing this recycling, I mean, for several and thousands of years altogether. And the available, and of course, after the nutrients is back to the soil, they are available to the consumers as well. I mean, they are getting back to us in that way. Yeah. So keeping that in mind, there are different varieties of fungus, or we can say the families of fungus. So first we talk about the mushroom. And of course, Annie, we were talking about the steak. We need some mushroom with it. And so when we talk about mushroom, it's the thalamus. That's what a mushroom has. So a stalk and the fruiting body at the top. So this thalamus makes a fungus, little different looking thing, which is this, what we get. And of course, all the mushrooms are fungus, but all funguses are not mushrooms. And then comes the mold part. So mold is very easy to see, like it happens on bread, on food, and a lot of other stuff. Even on, I think, wood, if it's like out in the moisture for a longer period of time, or your bleisure. If you are kept here in a cupboard, some whitish things also get in. So those there are different types of molds as well. So then it will be a topic on molds only. So so let's skip to that. The mildew. So it's not only human, nature has also get affected by different types of fungus, which sometimes can be a harmful one. Just like this mildews, which is like a bacteria, which happens in the plant, and they kind of kill the plant slowly because it damages the cell of the plant. You know, the cellulose of it, or we can say the cytoplasm in very specific. So the bacteria affects the cytoplasm, for which the plant loses its moisture, as well as the mitochondria, the powerhouse of the cell. All these things are gone because of this fungus. And then yeast. Yeah, yeast is like cakes. I love that. Christmas is coming, so we get a lot of yeast in it. And yeah.
Arpita, I think we should switch. You're freezing and breaking up a little bit. So let's switch the conversation to have no cameras. And I think then people will still see the photos. They won't see us chatting, but we'll have a better luck with the audio in the internet. So we'll turn our cameras off here.
Is it okay that you keep your camera on and sure, I can switch on my camera?
Sure.
Switch off my camera. Okay. That's okay?
Sure, just fine.
Yeah. So
we were getting up to the
yeast, yes. So yeast is something we use very much into our daily life. Starting from making breads, cakes, Christmas is coming. So of course, yeast is very much required. And pizza, love it. And of course, while making a homemade ginger ale, you need some yeast and sugar for the fermentation. So it's a daily thing for us. But imagine so many families. But how do they grow? If you go to the next slide, Annie, Look at this picture.
Yeah. Tell us about this, because I think we now understand a little bit more, although it's complicated, about these different things that we call fungus: the yeast, the mildew, the mold, the mushrooms. We know that they have some cellular similarities to animals. They're decomposers. Now, when it comes to growing, they do a whole different thing. We certainly can't grow this way. So tell us about this.
Yes, so it's very interesting, Annie, because for fungus, they kind of go through sexual and asexual reproduction. Both the things happen for a fungus. And in short, I would say that they can go by the flagella, like the breakdown of cell as well. But we today will talk about the spores. Just like how the seeds form in the plants and the seeds dispersal happens, the fungus does the same thing. See this picture, you would see numerous, like millions number of, or zillion, I would say, spores which are flying, which are bursting out from the gills of the fungus, and they are floating with the air and traveling where not, and they're reaching to their destination, and from there they start growing. If you go to the next slide, you will see that how it actually grow. First, you see the bigger picture, the fungus. You see the fruiting body of it there. So from there, the spores dispersed. It fell into the ground in the soil, and they are very fast growing creature. They grow really fast, and from there, slowly, they spreads their root. Here, the roots are called the hyphae, the single one. But when they come together, they call mycelium. And remember this word mycelium. We always talk about it, especially Annie. For last quite a few webinars, we have metamorphized with some other thing related to mycelium, and yes, so they are like forming. If you go to the next picture, so they really don't have like a root system, but they have a network system. And while talking about the network system, I would definitely would like to start from the beginning. Like very recently, a fungus has been discovered from the cave of South China, which scientists are saying, the mycologists, they are saying that it could be around 635 million years ago. I mean, this is a terrestrial fungus. Annie, you know that, right? I mean, that time our Earth was a ice ball.
That's exactly right. It's a completely different time in our planet's history. And we didn't have, a lot of plants and all of the things that we associate with our green earth. That was not present. So we know that this fungi is incredibly old and primitive. Tell us here about this picture with the 635 million year old fossil.
Yes, I mean, what
We're losing you a little bit, Arpita. You're breaking up a little bit. So I'm gonna talk about this this slide for a moment, and we'll see if you can come back in here in a second. So I'll invite you back in just a moment, and we'll see if things shift a little bit. So we know that the basic building blocks on our planet of life are literally connected to fungus. That is a crucial piece of information here. And remember when Arpita was talking about us sharing similar ancestry, but we also know that the presence of fungus helped the earth, as it says here on the slide, transition from a frozen ice ball to a place where ecosystems could host other life forms. So they're literally, I guess in a way we could think about it as soil, but that's the difficult thing about the fungus is we always want to think about it as something else rather than what it is. And it's just setting a foundation for this ecosystem. We know that the ancient fungus literally reshaped the chemistry of the earth. It paved a way. Now, this is really interesting to me. If it reshaped the geochemistry, we're talking about geo is rocks and chemistry is their makeup, right? We're talking about an actual shift in structures, which that also, again, we start to think like, well, how does that happen? We're going to check in and see if Arpita has something to say about this and if she's got a little bit of a better connection. So Arpita, tell us what you think of with this geochemistry and the fungus reshaping things on planet Earth.
Okay, I'm sorry, the connection. Annie, I could not hear you as well what you were saying, but the thing is like when the transition was happening, so okay, fungus actually a lot of filaments are there in the terrestrial fungus, and these filaments were holding. Hello?
Yeah, we can hear you. You sound great.
Okay. Suddenly I lost you, so I thought, okay. So these filaments were holding the characteristic of every living creature on this planet before the ice age. So they were holding it back. So when the earth started, the meltdown started happening, this fungus break down those organic matter and minerals and recycled nutrient into the atmosphere and ocean. So this ancient fungus had reshaped the geochemistry. So the chemicals, their digestive enzymes, and their ability to bring back everything to the soil or to the nature has really helped and paved the way for terrestrial plants and animals, and eventually they merged and thrived, and till date they are thriving.
So that's really interesting. And I think one way that people might be able to relate to that is when you think about gardening, or if you've been on a trip with us to an area where you see the retreat of a glacier, there are often plants that will come into the area, or after fire, you will see something called fireweed, right? Coming in after fire, or there are a few other plants that are good at this. Lupin can be good at this as well. And these plants are what we call nitrogen fixers. You will see as a glacier retreats, only gravel. It does not look like there is any soil there. The plant that is a nitrogen fixer manages to plant itself in the gravel. It can take the nitrogen out and use that as a resource. And then, of course, as that plant dies, it becomes organic matter. That is something that some of our gardeners might be able to relate to a little bit more, that concept of nitrogen fixing. So when we talk about this, we're really explaining the building blocks that we have of this largest network system. So Arpita, tell us about this.
Before getting into it, Annie, just imagine your life with internet or maybe without internet. Because right now we are connected to everyone, everything through internet. Like we are doing these webinars, we all are getting connected to each other through internet. It's a world wide web. And this web help us to get our air tickets, our paying our phone bills, and like ordering a pizza, of course. So all these things all are connected. Imagine a life which has like more vast network than this world wide web. I mean, that is huge, and which is created by this fungus. Their network is outstanding. If you just take the next picture, that white thing, those are the very closer picture of the mycelium.
Okay, I'm going to take over for a second because we're losing you again. I'm so sorry. Those of you who are hanging on, thank you, even though we're having some technical difficulties. But you're breaking up a little bit. So this is the mycelium. This is the building blocks that she was talking about, and this is how they begin. So when we are talking about this network, we are understanding that all of the mycelium around are communicating with each other. Now, how does that happen, right? When we talk about communication, that's just kind of, we think about talking or sharing a webinar or something like this. Structurally, when we look at a forest, we can know now that through the roots, there are fungus that are acting as a communicator to another tree. So if I want to communicate as the mother tree, I have 3 children. Let's just take this metaphor as far as we can. My children trees, I'm going to decide, just as I do as a human mom, who to send the resources to. Who needs some attention today? Who needs a little bit more food, a little bit more of these disease-fighting enzymes? That is going to happen through the fungal network. So these forests are all connected, and it turns out it doesn't even have to be the same species. So it doesn't even have to be my children. I'm going to communicate to the children in the school as well and think about the resources. They could be from a different family, but I'm still going to be sharing those resources. I know it's hard to understand, but that's what we know now these trees are doing together. And you can even look up some really interesting information about how that gets stopped. If you think about, we talk about greenways, right? Where we know that animals have an ecosystem over here. We build something like a highway or a city, and the natural migration and movement of those animals has stopped. This same concept happens with trees and farming. If an area of farming gets cut off from this network, then the soil productivity and the health of the plants will go down. And so farmers are now learning to look at that larger network as a way to help increase their production. One way to look at it is that the plants are literally sharing resources back and forth. The trees are saying, oh, you over there, I'm going to communicate that you need to get a little bit more of these enzymes. And we're going to communicate about, creating some shade over here. It's very hard for us to imagine. I mean, I spend a lot of time trying to figure out how whales who actually make noise communicate with one another, but it is through this network. I'm going to check in again with Arpita and see if she can come on to add to the things that we're talking about here. So Arpita, are you still with us?
Yes, can you hear me, Annie?
I can. You seem to be back. Is there anything you want to add about the network that I just described?
Yes, another example of it, that it has been proved that plants do a lot of chemical communication that we knew about, that they do exchange a lot of things. So if you go to the next slide, the networking happens, but there is a messenger in between who actually connect all the plant's root system. And those are the mycelium of the fungus, and they can be sprayed like kilometers after kilometers to send this, to transfer this message. So taking your example, there is another one I would love to add is, suppose any plant get infested by some insects, and they send the message to their family members that, oh yes, this is a larva which is feeding on our leaves and we are dying. I mean, without leaves the plant can't prepare their food. So the other plants will increase the toxin level in their leaves so that there are less infestation happens and the family can survive through it. And that's amazing to think about. And this whole network system, if you go to the next slide, this is like how our brain works, the neurons. There are electrifying things are happening all the way, every day, 24 hours. You see those current is passing with all the messages. So with the neurons, taking the neurons as the mycelium and how they connect, and all this chemical or the electrical communication happens just underneath our feet. Yes, and this whole system brought us again back that how all these fungus are incredibly intelligent, and with evolution they have taken a big part in the whole ecosystem. As you have mentioned before regarding the oil spill, so they are like, they have mastered in that, the principle that fungi are the best qualified organism of the environmental remediation, and the mycelium has been the fine-tuned like a billion years of evolution for one primary purpose, that is to consume. So they keep on consuming all the oils sorry, and they give away all the nutrients back to the nature. And there is a particular fungus, Annie, you want to talk about it?
Yeah, it really, this concept that a fungus could help clean up an oil spill, I thought, well, how does that like actually happen? And it turns out there's one species that is responsible for helping with that, and it's this white rot fungus. I think people probably have seen this in some areas. I don't think it's rare at all. But this particular fungus is quite specialized in a way of doing the decomposition that Arpita just mentioned, and can help with an oil spill. That ability to break down pollutants, whether it's oil or some other kind of pollutant, is really part of the sort of, it almost seems magical, but the science of what we're talking about here. Now, tell us then, there's that joke, an algae took a lichen to a fungus, right? That helps us understand the relationship between algae and fungus that makes a lichen. I bet you've heard that joke on almost every one of the NatHab trips. Tell us about lichens and what they have to do with this relationship with fungus.
So when we talk about lichens, that we know that they are the bioindicators, that where is less pollution, they grow more. Where there is more pollution, they grow less. There's the vice versa with the thing. But there is a big debate, and we know that the lichens are the mixture of fungus and algae. So, but there is a great debate right now that whether it's a symbiotic association or a controlled parasitism. Imagine a fungus controlling that. They just don't want to let the host die. At the same time, they are getting the benefits from the algae because they can't prepare their own food, for which they are getting the algae, alive, and the algae can actually spread more. So they are kind of connected and controlling it so that with the algae they can survive, and the fungus especially grow in the moisture areas. So that helps the algae to survive as well. So taking that in part is, we call this algae as the photobionts because they have the chlorophyll, and from the photons they can prepare the food. So it says that the photobionts also take some advantages of the fungus, because algae don't have the thalamus, but a fungus does. And everything they have to prepare, they need a bowl, right, to prepare their food. So here comes the thalamus, which helps them to prepare that. And over there, when the fungus digests everything, the nutrients which is getting back out of the cell, that is also utilized by the algae. So, and especially the component or the chemicals which are found in this process or in the fungus, that is not found in anywhere in nature. anywhere in nature. It protects it from the UV radiation, from the desiccation or grazing by the herbivores. So it's a huge topic again to get along with. Am I clear right now? I mean, am I audible?
Yes, you sound fantastic. And I think what you just described about the lichens, I'll just kind of summarize it for folks, that what we're talking about is that there's different organisms combined together working towards, is it a common goal, or is one of them getting more from the relationship? The fungus provides the structure and the algae provides the food. So together they give us what we call lichens. And I think that it's important for us to understand that just in the last 10 years, we have learned more about lichens than we thought they were for hundreds of years. It used to be that we would explain that it was one species of fungus and one species of lichen or of algae combined together, but we know now that it's two, if not more than that. And just that we're learning these things that, you know, we sort of think we've discovered the planet in a way, but it turns out these things that were right in front of us all along are much more complex than we thought. Now, this is an interesting one, a bioluminescent fungus. If any of you have been to the ocean and seen the bioluminescence, this is something that can't be ignored. It's the same chemical. The luciferin that is in the bioluminescence that we see in the ocean is the same that we see filling the bioluminescence for fungus. So this is obviously something incredibly beautiful. And I believe you see this where you are living. Is that right, Arpita?
Yes, I would say. And the more we see above the ground, and they grow in the very moist deciduous forest. Mostly you get to see this. And the more you see outside, the network will also contain the same thing inside, this all chemical. But with that, while we talk about that controlling the other like organism, I think the best example which is there in front of us is the cordyceps fungus. So where we also call it a zombie fungus because they kind of take the whole control of the body of the organism. Just like in the picture, the ant, you see some white mold part which is coming out from the head of the ant. So, and it also have been proved that the cordyceps fungus don't affect the brain. It worked with the tissues of the body of the organism, and the body control the brain to do some work, because if they hit directly to the brain, it will damage the whole system. So they affect the tissues and the system of the body, and that controls the brain. So it takes the ant far away from its colony, and so that's how it's like the dispersal happens, like where the spores can't reach. So they disperse themselves like that. So that's the reason why they don't want to affect the whole colony. They just select few soldiers from the colony so that they walk or they fly to a different area, and from there they start sprouting from the head of the organism, and slowly the fungus grow on it.
It sounds like it's right out of a science fiction movie, right? That this species comes in and takes over the body and forces it to go somewhere else. Zombie is an excellent name for that. And there's another one here that is another sort of colonizer. Tell us about this one.
Yeah, this is a funny thing, Annie, and now it is economically also people are getting a lot of advantage because of this fungus. So this is a ghost moth caterpillar. So this moth actually laid an egg in the crevices of the soil, and where in that small area the caterpillar grows, and they come out by piercing or any crevices or hole from the ground. So what happens, this fungus, or like the cordyceps one, I mean the same one, which affects this one, and this is also called the Himalayan Viagra. this fungus. Yeah, and they have a lot of medicinal, it says that it has a lot of medicinal values, and of course it immune your like booster and cancer treatment, but it's all like saying that it happens. So that's how people I mean, they can't cultivate it, so a whole community depends on this fungus. Because in the mountain, if you go in Himalayas, there are a few places where people walk miles over there, and they keep on picking up all this fungus and bring them to the town or the cities, and they sell it in high price, and of course they get money out of it. And those people do nothing apart from finding out all this fungus.
Wow. That's amazing. And then there's other ways that we are learning about fungus potentially helping us. We're getting really close to the hour here, so we'll talk about this quickly. But psilocybin, everyone has heard of magic mushrooms or people tripping, this kind of thing, where it's used as a recreational drug. But now there is research being done that shows that it actually could have huge mental health benefits, not in the recreational drug way, but as a pharmaceutical. For the first time in the United States, I believe it was just a few months ago, the FDA approved a formal study of the psilocybin to see if it is as beneficial as some practitioners are claiming. So it will be very interesting to see how that sort of shapes up in the next, few years here relative to that research. Right now, there are certainly people who are huge proponents of this and say that with the right therapeutic conditions, it can be incredibly helpful for healing from trauma. So I'll be watching that for sure, just to see how that progresses. What about where you are? Do you also know of sort of medical investigation into these, the psilocybin, or what used to be called, magic mushrooms?
Over here in India, it's not there. It's already, I mean, it is illegal, of course, to take any kind of drugs and like. But at the same time, mushroom, we got the penicillium, right? So the antibiotic. So if we think about that, but it's but mainly magic mushroom, we say it could be a breakthrough for the treatments, as you have already mentioned. And currently people are doing a lot of researches, and they are kind of being interested, what do you say, like volunteer. People are volunteering into it, that how exactly it feels, like how you, especially for like psychedelics, which is more on the psychiatric side of it, that you have a bit and then a lot of stories, and you go to the depth and you bring out all your memories and stories, and you merge yourself with the nature and with the power. But these all are like hypotheses.
Yeah, exactly.
Till date. It's not like completely proven.
Right. So we've talked about, this is called chicken of the woods. It's something we see here in Alaska. We eat it. We know about the mushrooms that we mentioned, the mushroom that goes with steak, or just what you find, shiitake or portobello, all these different kinds that we eat. We've talked about the mold and the mildew and many benefits that the fungus has for people, whether it's the psychiatrics that are being studied or the actual structure to create a healthy ecosystem. I want to dive really quickly before we take questions, just to look at these maps. So for the first time a couple of years ago, the Nature Journal published the map that describes sort of where this massive network is that we are describing. So I won't get too far into it because we're at the end, but there are different kinds of microzobial species that go into different areas. So there are some that go into the high latitude regions with cold and dry climates, and the one that I just showed before are the ones that will go into the hot and wet climates in the low latitude regions. So we're actually starting to map where these networks are, which is a fascinating step towards moving toward this. I also wanted to show you some books that we found incredibly helpful. Entangled Life is, I quoted from some of that research at the beginning there, Merlin Sheldrake, what a great name. He did phenomenal research, and I think what's so incredible about his book is he actually dares to go into some of the bigger questions. You know, religious scholars have opinions on what is going on with this network. So he kind of delves in and out of some of that philosophy, as well as he's an incredible scientist who is studying these things. The Hidden Life of Trees is another excellent book that talks about the communication and the sharing of resources and that kind of thing. And then finally, Fantastic Fungi is another book that's excellent. And then we mentioned in our last webinar, Susan, I think it's Sherwood, I might be saying that wrong, from British Columbia, and she did also some very incredible work. So I'm going to go back to something here. We'll sit here for a moment. And Arpita, do you have anything to add before we shift over to questions?
No, I think for today's webinar, this is fine. And a lot of questions is already, while doing this webinar, I think a lot of questions come to mind, and I think that the same happened to the guests as well, because we are having in a pool of questions right now regarding this fungus. So let's take questions right now.
That's great. And you're breaking up a little bit, but I know what you said is that this came from questions. So we mentioned a little bit of this in past webinars, and you all, the viewers, asked questions about what we brought up, and that's why we did this today. So Rob, do we have any questions out there?
Thank you. Oh, before we start the question and answers, I'd like to remind everyone that you can submit your questions via the question field in your control panel. So yes, we do have a couple of questions. First of all, can you repeat the fungus lichen joke for us, for those of us who did not hear it?
Yes, an algae took a lichen to a fungus. And so this is just a little joke to help us remember that lichen is the combination of algae and fungus.
Great, thank you for that. So it was really interesting to hear that the fungi also exist in the oceans as well. Are they in fresh bodies of water, and how do they differ from the fungi on the land? And do they do the same job?
That's a great question. There's not only in lakes and ponds and streams, yes, there are freshwater fungi. There's also fungus that the spores can intercept with water, like rain, and then they can start to affect even our weather. And this is the part that gets really mind-blowing when you start to think about that. I would say that there's probably some really big technical differences, but I can't name the species that are in fresh water, say, versus salt. Arpita, do you have any details on the difference in that? I wouldn't suspect there to be too many.
Yeah, not yet, Annie, because it's still on the study. But as you say, that it makes it up like all this, the stones, especially, which is the hardest part of it. The fungus grow there because of the water, and the spores come together. And the same thing happens there, but there is no like species description to it yet.
Great, thank you. And are there particular lichen in the ocean as well, or lichens on
land? That's a good question. I have seen lichen that are on. I've seen lichen in intertidal zones, I believe, that are, but they're on something. So I don't want to speak to what is actually in the ocean. Boy, do you have something on that, Arpita?
No, I don't think, Annie, because for lichens, they need air, because from air they get the, the moisture and the fresh moisture on that, but not in the ocean, because salinity doesn't work with the chemicals they produce in lichen, or rather in algae.
Okay. Yeah, I just Googled it just to see what I could find, and it does seem that the tide level is important. But I will say that I love this question, especially as someone who is so interested in marine life. And so I'm going to be looking into this and seeing if I can learn more about it. So whoever asked that question, kudos to it. I love it.
All right, can you clear up a little bit about the mycelium? Is it a fungus itself, or is it part of every fungus?
Ooh, I love that question.
Annie, you want to take that, or
you go ahead, Arpita. Yeah, go ahead.
Okay. So this fungus is a part of the fungus. Just like imagine the tree with the root system. The same thing happens with the fungus. The fungus is like the root of the mushroom, or the fungus, actually, the mycelium. So it keeps on spreading, it keeps on dividing, because each and every mycelium has a small part which is called the hyphae, and every part has a nucleus. So they keep on breaking down, they keep on spreading the network and how it goes. So it is well connected to each and every mushroom and each and every root of the tree. So is that okay? I mean,
yeah, that's a very good answer.
So you were talking about they found fungi in stone. Did they have any explanation for how it got in there? Can you expound on that at all?
Well, I could say that, you know, when we think about how water can move its way into stone, and it freezes and then it melts and then it freezes, and that ends up cracking the stone apart to make some space. I imagine that that is similar to how fungi would get into a rock. However, when we learn that the actual geochemistry is changed, that's where we know it's much more than the description I just used with water, because that's where the fungi is actually taking and using and transforming the molecules of the rock, which is like pretty, you know, it's kind of mind-blowing in and of itself right there. But I think back to those nitrogen fixers. That's the best example I know of from sort of what we can see today is happening, the ability of a plant to also extract from a rock. So I would say that it's similar to that.
Very interesting. So let's talk about the fungi that ingests oil. Now, is it used for large-scale spills, and what does happen to the fungi after it does eat the oil?
That's a great question. I'm going to let you take that, Arpita.
Yes, thank you. Yeah, that's a good question. The thing is, it has happened that they have the scientists, while they got to know that the fungus can consume whatever they get, even the oil spills. I just forgot the name of the place where it has happened, but they have started, like the men who are working on it, like physically, and they have put some fungus over there. The spores especially burst after a few days, and after like 10 to 12 days, when they came back, they started showing the green thing growing on that same area. So it seems like the fungus work really fast. And of course, because we see the growth of the mushroom, which is really quick, so same thing happens over there. They can consume a lot more things way faster and efficiently, rather than any human, like any artificial manner, how human can do it.
Wow, intriguing. So using the internet network metaphor, is it fair to say that fungi is the internet backbone and plants are sort of the user network people?
It's interesting. This is where that book Entangled Life gets really important, because the biologist there, let's see, he's got such a cool name, Merlin Sheldrake, he would say that it is far more cooperative and complex than using the World Wide Web as a network. It's a great example. It's a great sort of metaphor for us to understand how vast it is. But in terms of the interaction between trees, as this guest wisely said, is that the sort of internet user, it's just way more complex. And I have to say, as Arpita and I were researching this, we'll chalk this up as one of the most difficult webinars to make, because every time you look up some aspect of this, like the concept of the worldwide fungal network, it just opens up tons more information, and it gets large as this vast network, I guess I'll say. So yes, that's a good way to think about it in terms of the tree being, me here using the internet. But I will say that I think it's even more cooperative and more complex. And I think that's a good way to sort of explain, because it's interacting with everything. It's not just the tree.
Yeah, sorry, no, you finish it. Just I'll add on
Arpita,
it.
you got this. Yeah, you go.
Yeah. So, and that's a very, I mean, that's a really nice statement by the guest. And when we talk about the consumers, for tree, imagine all the fungus, they are using not only the networks, but also the nutrients, because what the fungus are decomposing, and with the digestion and the breakdown of the organic things and bringing out all the smaller to bigger molecules, with that, they are also converting everything into a nutrient and the carbon level, which even the tree is taking, I can say, advantage of the fungus. So yes, it's not only by the network, but it's a huge system, and we can't ever stop plunging in it, I guess, Sani.
Okay. Well, thank you for that question. It's a good one.
Well, unfortunately, that's the last question we'll have time for today. So I'd like to hand it back to you guys for closing comments, starting with you, Arpita.
Oh, thank you so much, Rob, and thank you everyone for listening to us. This topic is pretty much new for both of us, I think, Annie, and it actually came because of all of you. Unless you have asked the questions in our last webinar, we wouldn't have come up with this topic. And while doing this, we have learned a lot. So thank you for giving us a chance to know something very new, and hope we will learn like this something more in future. And thank you so much for tuning in today.
And thank you, Arpita, for joining me and working collaborative with me so we can explain this to folks. I can't wait to keep on learning with you. And I know it's past midnight where you are, so I just want to point out like how cool it is that you're willing to contribute to this, even when it's so very late where you are. I really want to thank all of you for joining us. We love doing this. We even love it when we have hard ones like this that require us to really dig in and learn more. That's the best part of our job. So thank you for asking those great questions. I will be back next week, and yeah, hope you all have a wonderful, wonderful day.
Thank you so much for taking the time to present for us today. And I'd like to also thank everyone who tuned in. Join us tomorrow for our next Daily Dose of Nature. You can check out this week's lineup, including registration links, on our website at nathab.com/webinars. We did record today's presentation, and we will have the replay available on our website soon. With that, I will conclude the webinar. Goodbye, everybody. See you next time.